Alright, so we have a system of three equations, three variables. We need to decide, are we eliminating the x's, y's, or z's from all of these? So we have 1, 1, negative 2, negative 1, negative 2, 2, negative 1, negative 2, negative 1. I think I agree with you. I think I would eliminate the y's because two of them are already opposites. So I agree with you. We're going to try to eliminate these. I think that would be the easiest, but really any of them would be okay. And so the first step is you write down the first two equations together. And then you write the last two equations together. And once you see this, you'll see it's really not too bad.
Is the y the rise or the run? Y goes up, so it's the rise. Okay.
So all I did so far is I have decided to eliminate the y's on both. You can't do y here and x here. That won't help you. You have to do consistently the same thing. And I wrote the first two equations together, the last two equations together. So I have decided to eliminate the y's. So I need to make those opposites. So easiest way, if this is negative 2, make this a positive 2, I think, by multiplying by negative 2. You see that? Or multiply by 2 and subtract. I don't like subtracting. So that's negative 2x plus 2y plus 2z. And negative 2 times 0, still 0. The other one I could leave alone. Now this problem is actually going to be easier than the others. Okay. Now when I add these together, that'd be negative 1x. Eliminate. And this is why I'm saying this problem is actually easier than most of them, because usually they don't both eliminate. That's just random luck. So then we get negative x equals 3. They usually aren't that easy. This is a poor example to show you as a one to prepare you. But let's see what we get with the second one. The second one, I could just add those together, and just to be consistent, I'm going to keep this the same. Keep this the same. Add them together. And they're already opposites, is why I'm adding them together. That's negative x. Those eliminate. That's negative 3z. And that's 6. So normally what you have is you'd have x and z, and you would take these two green equations and put them together and solve like you would any way you want. Does that make sense? Normally you would still have a z here. And so you would take this one and this one, put them together. But this one's actually pretty easy. What?
As like a separate systems of equation?
Yes.
Like as if you're going back to the first one?
Yeah, so then you would take both of those and you say, okay, I got negative x minus 3, or equal 3. And I have negative x minus 3z is 6.
It's not really harder, it's just a longer process.
And so normally you would have a z here too, and now you got to solve this probably with elimination. That's all. That's the only difference there. Now this one's super easy, so x would be what, -3? See that?
Yeah.
And then you already know negative x is 3, so you could just replace negative x with 3. Or you could think of it as plugging in -3, negative 3 makes 3. And so I could use that to find z. Minus 3 from both sides. I don't know if anyone in here needs this, but I'll put it on there. Divide by -3. And you get z as -1. And then from there, you need to find your y value. So you have to go pick one of your original equations. I'll just pick the top one just because it's there. Looks easy. But I know that's -3. I know this is -1. Should not have drawn it in that way. So I get -3 minus y minus -1 is 0. That'll be -3 plus 1 is -2. Add 2 to both sides. Negative y equals 2. And then so that means y is -2. And so you would say your solution is x, y, z at -3, -2, -1.
I think there really isn't a graphing method, is there?